Next up, we have sorry, Frederik Rothenberg from software engineer at DFINITY on how to build and deploy smart contract in less than 1 hour. Frederik, thank you.
So, hi everyone and welcome to this workshop on how to build and deploy a smart contract on the internet computer in less than 1 hour. And this is just the agenda of what we're going to do. So I will first give you a quick intro to the internet computer, then we'll write a smart contract on the Motoko playground. And up to this point you don't need any software installed on your computer, you can just need a browser and some internet and you can code along. And after that, we'll get some cycles from the cycles faucet. So the promo code that you just received is valid there, or you can also register with your Twitter handle. Then we will bootstrap the front end with our SDK. Afterwards, we'll adapt the front end to our needs, make some changes there. We will integrate with Internet Identity being the identity provider of the internet computer, basically a platform service that we offer as well. And then, since we're a little bit strapped for time in this hour, we will deploy directly to production, directly to the internet computer, as any responsible software engineer would, right? And then we will wrap up and maybe answer some questions, and I'll give some hints to other resources and documentation. And yeah, so let's get started. So first and foremost, the prerequisites to code along are, well, it's really helpful if you have this slide deck. The link is also available on the promo code that I just handed out. You then need a Linux or Mac machine, or if you're on Windows, you need to use the Windows subsystem for Linux. Then we rely on Node 16 for the front end, and then you also have to install DFX being our SDK command line tooling. You can install this by just executing this command, or if you don't like piping any random script into your shell directly, you can just download the file, inspect it, and then execute it. And of course, all the code that we're going to write in this workshop is available on GitHub as well. Right, so what is the internet computer? So the internet computer is a level 1 blockchain network that's formed by the internet computer protocol. And because it's not just a single blockchain, but a blockchain network, it is infinitely scalable. So we have, whenever we have too much load, we can just spawn another subnet, another subchain, and execute transactions in parallel. And it's not only fast because we can scale to a high number of chains in parallel and have high throughput, it's also really fast in general on a single chain. So our consensus algorithm reaches finality in 1.5 to 2 seconds. So this is what we call web speed, because it's actually fast enough to do HTTP interactions directly on chain. And we also have a governance layer, so basically the whole internet computer is one big DAO. So if you hold ICP and you stake them, you get a vote in the governance smart contract, where you can influence in which direction the whole project is going to go. You can vote on software updates, for example, to the replica being the software that is run on each node machine. And this makes the whole system very adaptable and future-proof, essentially. And so the whole system is run on special node machines, so it's not like AWS or the Google Cloud Platform or anything like that. So if those guys go down or have some infrastructure issues, we will keep on running. And yeah, like all blockchains, it's unstoppable, and the code, the smart contracts it hosts, is tamper-proof. Right, but in this workshop, we're going to take on a little bit different perspective, because we're going to treat it essentially like just a serverless platform to run our code on. Because you can treat the whole internet computer as a cloud platform, if you will. And we will deploy a canister. This is what we call the smart contracts on the internet computer, which are just WASM modules. So you can write your smart contracts in any languages that compiles to WASM. But we have special support for Rust, where we offer an SDK, and also Motoko, which I'll come to in a moment, which is the special purpose language that we created at DFINITY to write those smart contracts more easily. And so in this workshop, we're going to push actually 2 WASM modules onto the internet computer, and you can then access them with your browser hosted from the internet computer. So, about Motoko. So Motoko is our specialized programming language to best use all the cool features that the internet computer offers. This means it has native smart contract support. It's strongly typed with a modern type system, so you can do all the fancy stuff like destructuring values, you can do null checks, so in the type system, stuff like that. It also has first-class support for the asynchronous actor model, so a smart contract on the internet computer is represented as an actor, which is an entity that just holds or encapsulates all its state and communicates with the outside world using only asynchronous methods. And actors are, in Motoko, actually a keyword to write them really simply, and you will see that in a moment. Then we also have the concept of orthogonal persistence, which basically means that it's abstracted away from you, that you're actually programming a distributed system that has the state replicated all over. You don't need to deal with that at all. And also it gives special support for the different types of memories that we have. So for once you have the heap, which will not be persisted across upgrades, but you can use as you're used to when programming anything. And then there is stable memory, which essentially are just memory pages that you can put data in that will be kept across upgrades. And then if you use Motoko, it can generate the interface specification of your smart contract automatically. So the interfaces of all the smart contract and also of how you interact with the stable memory layer are described in Candid, which is our interface definition language, and this can be generated automatically. And the cool thing about it is that it detects when you do changes to your smart contract that are not actually backwards compatible. So if you really want to not lose data, so it's really important to have to have compatibility when upgrading your smart contract. So if you do make a mistake and you try to deploy a smart contract that will actually break when reading the existing memory, it will warn you. And also the same thing for the external interface. So if you have other smart contracts relying on this one and you break the interface, you can still go ahead and override the warning, but you were warned that now stuff is going to break. Right, so the Motoko Playground is an easy way to get started with this new language because it's also a smart contract hosted on the internet computer that offers an interface, a code editor, I will show that in a moment, where you can play around with Motoko code and also deploy stuff right on the internet computer. And if you open up this website, you should get a list of examples that you can choose from. And please do select the counter example, which is basically just a really simple counter where you have a number and you can count it up. And we're going to change this example to bring in identity into that, so that every one of you that logs in into this front end can have his very own personal counter to count up. Really exciting stuff. So Also, on a side note, this URL, we're actually working on that to make it more readable, more palatable, but we're still not there. There are a lot of features to be developed, and right now, basically opening the slides on your own device or scanning the QR code is probably your best option. Right, so if you have opened up the Motoko Playground, you should see essentially something like this, or at least if you select the main Motoko file to the left. And what you have here is the editor with the Motoko code and nice syntax highlighting and what you would expect. And then the most important button, which is the deploy button, right? And once you hit that button, I have actually kept my promise. You have already deployed a smart contract on the internet computer. Of course, I'm joking a little bit because this smart contract is not actually yours. You're not controlling it, and it will be destroyed after like 20 minutes. And it's just for playing around. So we're going to do it properly. But this smart contract actually spawns real other smart contracts for you to play around with. And once you do that, you get a candid UI on the right, which is a graphical representation of the interface that your smart contract has. And you can play around with those buttons to actually send messages to the internet computer and see the results and see the canister calls, as we call them, execute. And you can see that we have two types. We have query and call. And the difference there is that queries don't do state changes. This means that the response doesn't have to go through consensus, and this is much faster in responding to your query. And calls do state changes, and if you do play around with these things, you should see like a difference of about 2 seconds in speed. But state changes still are pretty fast, right? And also, if you deploy, you should see a little bit of log output, and you can see then your canister ID that was assigned to this smart contract. And you can also interface with this from your command line tooling, which I'm going to show in a moment. So, what are we going to do to this very simple counter example? Well, this essentially. So I'll walk you through the code and what we changed, and yeah. So first of all, we're going to import some modules, basically the hash map, standard hash map, and also a principal, which is the object to represent an identity. So each smart contract and every developer tool that interacts with the internet computer has a principal, essentially an identifier. Then I changed the actor to the personal counter actor to represent the changes that we're going to make. And then now, instead of the just natural stable number that we had previously, we now have the counter's hash map that we initialized to like size 10 and with the principal equivalent hash functions. And also, you might notice that we did remove the stable keyword. And this is because higher typed objects cannot just directly be serialized to stable memory because they might have code associated with it, and this code might change. So in order to make sure that it doesn't break on upgrades, you're only allowed to use primitive types for stable variables. But this would kind of be too much for this workshop, so we'll just keep the stable keyword away and just be aware it will lose all your personal counting stuff when you do an upgrade. Then we need a helper function to get the count out of the hash map, because the hash map might not actually have a value for any given principal in there, right? So what you get back is not actually a natural number, but an optional natural number. And what we do is we switch on the possibilities that we have. So essentially we have a maybe counter, then we can unpack this and just return the counter. Or we have something else, which in this case might just be null. And in this case, we return 0. And then we have the public interface methods, which are the get function that we had previously, but we made some changes here as well. So we added this parentheses with the caller inside. And what is happening here is that we're essentially accessing the call context, and we're immediately destructuring it in place. So the call context has additional data associated with it. So the message size and cycles that might be sent with that message and stuff like that. And here we are only interested in the caller, so we're kind of destructuring the object, throwing away the additional data that we don't need, and just pull out the caller. And then we can use the getCount function with that caller to retrieve the count. And also we need the call context on the increment method, so we added this shared keyword to get access to the caller in the same way. And then we can just override or add the entry for a given caller and the count of that caller +1. Right, and we really remove the set method because we don't have a use for it right now. And now, how do you actually test that this whole identity thing works? So if you deploy this from the Motoko playground, you only ever get the anonymous principal, which is one specific value essentially representing that we have no idea who you are. And so to switch identities, you can actually use the developer tooling, DFX, that I showed on the prerequisite slide. So if you install that, you should have that available. And you can then interact with your canister that you just deployed by doing DFX canister and then -- network IC to tell the tooling to actually go to production and not just try to interact with your local replica. And then the canister ID is this value that you got when deploying, right? And you can then call the name of the method that you want to call, so get or increment. And you can switch identity by doing DFX identity new and give it a name, and then you will create a new identity. You can use an identity to switch back to another one. You can also do DFX identity list to get all the different identities that you now have. And you can now verify that you actually get different counts for different identities, right? But so now we're going to switch over to actual coding with real tooling. So leave the Motoko playground. So again, the prerequisites, if you missed this previously. So most important thing, you need Linux or Mac or Windows subsystem for Linux, Node 16 and DFX. So to continue, you now need like the card that I handed out, the promo code for the cycles, because we're going to actually deploy a real smart contract that you personally own, right? So you have to pay for that, and you pay for that with cycles, and you get some cycles if you use your code or your login with Twitter on this application, and it will walk you through the process of how to actually get the cycle and what to do. And it's actually pretty easy. If you already have DFX installed, it's like a single command or two. Yeah. And in the end, if you have completed all of this successfully, you should get a really big number back when you query what your balance is, right? So you can do DFX wallet -- network IC balance, and you should get back a number about 20 trillion cycles. This is actually quite a lot. So this is $20 worth of computation, and it will keep you going a long time, even after this example is completed for a long time. Also, be aware, if you create new smart contracts, it will actually initialize those with 4 trillion cycles. So if it looks like you're spending cycles really fast, they were just reassigned to your other smart contracts, so they have a little bit of computation to keep going, but you can actually deploy other stuff into those smart contracts or delete them again and retrieve the cycle. So they're not actually used up and you don't have them. You can also query with the status call to see how many cycles there are left. So now, to bootstrap the front end, we actually have a helper tooling for that. So you can do DFX new and then a name. In this case, I did personal counter, and this will create a bunch of files for you. Essentially, it will create a new folder with that name, and in there it will do a DFX JSON file, which is our project file. Then we have a git ignore, because this folder will be already initialized as a Git repository. Then we have a README with additional resources and instructions on how to run the whole thing and what to do with it. And then we have the package JSON and the webpack config, which are there to bundle up and build the front end. And then we have the source folder. In the source folder, we have two subfolders, one for the backend, which is just named personal counter and should contain a Motoko file called main Motoko. And then there is also another folder, personal counter assets, which is the front-end files. And in there you have some JavaScript, some HTML, a logo, some CSS, a favicon, some random test asset to just make you aware that you can put anything onto this asset canister. So essentially we have this asset canister, this asset smart contract, which is a pre-built smart contract that acts as a web server and just hosts static files, right? And you can push anything in there and serve anything from the chain directly. So if you have done that, and if you have all the files ready, please go into that directory and run dfx deploy --network IC from there. And this now will actually push all the code that was automatically generated of this hello world example into the internet computer. And it will, of course, only work if you do have the cycles to pay for that. Right. And now, please overwrite the main Motoko file in source personal counter with the code that we had from the playground where we made the changes so that it's now a personal counter, and run this dfx deploy --network IC again. Because what it will also do, apart from actually updating the smart contract on the chain, it will also generate some JavaScript bindings for you to use in the front end, which is really convenient. So in your personal counter assets folder, source declarations, you should now see a personal counter folder, and in there you should have 3 files. One of those is the .did file, which is the candid interface description of what your service actually does. Then there is a JavaScript file, which will make it very easy to interact with your smart contract, because you can just pull out an object that actually represents your backend in JavaScript, and we will see that in a moment. And if you use TypeScript, you also have TypeScript typings in there automatically generated, which is also really nice to have. Right, and also if you did the dfx deploy with the initial Hello World version, and again with your new code that you just pasted over the existing main Motoko file, you should now see this warning that you're changing the interface. And please go ahead and skip the warning and override it with the code that we just did. Right, and now we're going to adapt the front end. So what we want in the end is that we have a page that shows the principal, so our identifier, who we are, and of course the counter that belongs to that identifier. And we want to offer buttons to increase the counter for the currently used identity. Then we want to be able to log in using internet identity, which is our platform IDP, and to also log out again, get back to the anonymous state. And to do that, we have to implement the JavaScript logic for all those buttons and for the updates of all the fields. And I'm going to walk you through this shortly. But first, I talked a lot about this internet identity thingy. And so this is basically some screenshots of what it looks like. And it offers to all the apps essentially the sign in with Google functionality. So it seems to, it feels very much the same way, but it is fully decentralized and governed by the IC governance system, and also anonymous in a sense. So you don't have to personally identify it. It will just kind of recognize you again if you come back, right? And it's also creating different identities for each step that you're using. So it's not that you can be tracked on the internet computer if you use internet identity. It will actually kind of separate all the different smart contracts that you're using from each other by assigning you different identities. So the changes in the index HTML that we're going to make is essentially in the main block. We're just keeping the logo because it looks so nice, and then we'll add 3 divs in there. So in the first one we have like 3 buttons, one to increment the counter, the login button, the logout button. And then in the second div, we actually want to display the counter. And we have a label for that, initialized to anonymous, and also the content box that we want to paste or fill the counter in with JavaScript later on. And then we have the last div for the basically the same thing, but for the principal. So for the identity. Yeah, and please add some IDs in there so that you can reference it from JavaScript, right? And then we have to adapt the CSS file, and I'm by no means a front-end design guy, so if you have any other ideas how to make it look better, please go ahead, do your own changes, go wild. This is just the smallest div that I could find that somehow made it not look terrible. And also, it seems like the formatting got a little bit messed up here as well. Yeah. Maybe it's better if you access the slides from your own machine, right? Anyway, not that important. And then we have the JavaScript file. I'm sorry for this slide. This is the most dense slide that is in this presentation. I promise it will get better again. But I walk you through it. So first of all, we need to install a new library to better interact with Internet Identity. So we have this @DFINITY auth client, which makes it really easy to log in and to use the Internet Identity service. And so, again, the formatting got a little bit messed up. But anyway, let's walk through it. So at the top, we're importing just some stuff. In the first line, notably, we do import the auto-generated stuff from declarations personal counter. So if this throws an error at you or there isn't actually anything there here, it's because you need to deploy probably again to generate those files from our tooling. Then we import the functionality to interact with smart contracts and also to do that over HTTP. And we also import the auth client to interact with Internet Identity. This is from the library we just installed with npm. And then as a very first thing, we will assign, so we can import a pre-made actor to interact with our smart contract from the generated files, and we'll assign that to some global variable that we change later on. And then we want to do a update of the counter when the window loads. So we do the assign a function to window on load, and this update counter function actually is a async function that calls actor.get, and this get, since this actor is the auto-generated object from your smart contract from the backend, it will have all the methods, all the interface methods that you wrote in Motoko. It will have available here on the JavaScript object to call nicely. And we await the result, and then since this returns a natural number, which is an unbounded integer, positive one, it returns you a big int, so we have to change this to a string, and then we can assign it to the DOM element with the ID counter, so to the inner text to see the counter in the website. And then we also declare a auth client variable to later put in the to store the auth client that we use for identity to then be able to log out again, but we'll get to that. So now the increment button. To make the increment button do something, we add an event listener on click on this increment button element, and essentially we just have to do two things. We have to await until the increment function completes, and then we just update the counter to see the new value. And then after that, we have the login button, and this is probably the most complicated functionality, but it's really easy once you see how it's done. So we also add a event listener on click to the login button. And so first of all, we have to use the auth client library to create an actual auth client. And then after that, we want to do the login. And in these few lines, the meat of this is actually in auth client.login. So here we call the login functionality of this client. And since this auth client works with callback functions, you have the onSuccess and onError callback hooks. But I was a little bit strapped for space, and it still messed up the layout. But anyway, so I wrapped this all in a promise. So on success, we do resolve, and on error, we reject. And we immediately await this promise. And so on line 25, we are actually authenticated. We're logged in. The whole identifying process is completed at this point already here. And so what will happen from a user interactions perspective is that it will open a new tab, a new pop-up. You then have to authenticate using biometrics or a FIDO key or anything like that, just using WebAuthn, and you have to acknowledge that you're authenticating for this smart contract, and then you'll come back and you will be logged in. So now we can pull out the actual identity from this auth client and construct a new HTTP agent. So this HTTP agent will then interact with the internet computer using HTTP and use that identity. And using that agent, we create an actual actor that is purpose-built for our backend. And to do that, we give it the IDL factory, the interface definition, which we also pull from the declarations up here. Then the actual agent to communicate with, and also the canister ID. And here our Webpack build process comes in handy because we can just pull the canister ID from the environment variables. Be aware that this is obviously dependent on how you named your example. So if you didn't name it personal counter, you have to put in whatever underscore canister underscore ID, right? And then what we do, we'll just update the labels so that it now says your personal counter, and we will okay, and yeah, and we will assign the principal. So we get the principal from the agent and write in the principal, and then we'll do also update the counter so that we see the new counter value for this identity that just logged in. And then lastly, we have the logout functionality, which is also just an event listener on click for the logout button element. And we can essentially, we need to do two things. So we do auth client.logout, and because we do use the auth client here again, we assigned it to this global variable earlier when doing the login. And we also switch back the actor that we use to the initially created anonymous personal counter actor that we could import from the declarations. And then we reset the labels to say anonymous counter and the principal to anonymous. And then we do another update to fetch back again the actual counter of people not being identified. So, and now if you deploy that, you should essentially see some console output like this, but most importantly, in the end, so it should update all the assets that we just did and print out a URL of your smart contract of the front end. And if you open that with your browser, you should actually now see your HTML page being rendered, being served by the internet computer, 100% on-chain. And you can interact with your smart contract just as you designed the website to be, right? And so I did a demo deployment of that whole thing. So if you didn't code along or it didn't work for some reason, you can try it on this website. And so do play around with the buttons, register on internet identity to create a new identity anchor and try out different identities. And yeah, if you press the increment button, be aware that it takes like 3 seconds to update the value, which is, I think, still pretty fast. Yeah. So to summarize what we just did is we deployed actually 2 smart contracts on the internet computer chain, and one of those being a front end with assets, with images, with well, a whole front end essentially, and this is 100% on-chain. So there is no complicated tech stack, there is no AWS involved, there is no black magic going on, it's just the internet computer. And we integrated with internet identity as well. So the whole identity topic is solved for you in a pretty easy way. And yeah, it should look something like this. Right. So, and also it's important to note that we did not do some things, right? So we did not do deploy locally because this would have made us deal with different environments where the canister IDs of the services we use are different, which is a little bit more involved, and we didn't have the time for that here. And we do not keep the state on upgrades, as I remarked earlier. And also, while the internet computer does scale seamlessly and can host many smart contracts as you want, your personal counter one doesn't. So if you suddenly get like 1 billion users all wanting to have their personal counters on your personal contract, you're going to run into problems with space, with throughput, with stuff like that. So you still have to kind of think about scale a little bit when you deploy stuff on the internet computer, but the infrastructure is there, so you can kind of do sharding, you can do whatever you like. So if you have questions about scaling, you can also reach out to us however you want, right? The ONT forum, for example, is a good place. Right, so more information about the whole thing. So if you visit smartcontracts.org, this will lead you to all our documentation that we have, like explanations more in depth on how the whole system works. Yeah, we have a forum. Please reach out to us, engage in discussions. We're very active there. And if you have questions on very special topics, we'll most likely find the exact guy that decided this, that explaining to you why and how it has to be this way. And also, if you're just interested in some cool stats on how the system is working and the status of it, you can also visit the dashboard, and there you can see like the number of smart contracts that are already running on the IC. You see the message throughput that we have, the number of blocks per second that we create, our governance proposals you can see there as well. So you see how like what stuff is being voted on and what the result is. Really cool. You should visit. And yeah, so also if you did all the steps that I just showed you, you should then end up with something as exactly as in this repository. So if you want to see the reference example of where you would end up if you did all that, you can visit this repository on GitHub. And also, if you would like to see more involved examples, more complicated use cases, we have a whole examples repository with many, many different examples in there. There's also like one that does end-to-end encrypted nodes, which is really cool. And yeah, I mean, check it out. There is also Rust examples in there, and not only Motoko, and there are also examples where you see both of them contrasted. So you see the same code in Rust and in Motoko, so you can compare and see how those different languages kind of play out when writing a smart contract. Also, really important, we have a hackathon going on right now. We have a huge prize pools and grants giving out. So if you have a cool project idea or have something in the already building, please sign up, deploy it to the internet computer. Yeah, it's still going on until June 20th. So you have plenty of time to build something really cool, since it only takes an hour, right, to deploy something. So please take part. All the information is available on DFINITY.org/supernova. Yeah, and we'll be happy to hear from you. So thanks a lot for your attention. Are there any questions? So did anybody actually succeed in deploying what I showed you? Okay, maybe you can try again later on, a little bit slower with the slides. The link is on the promo codes as well. So if you need a promo code, just come up here. I'll hand out more of them if you need one. Yeah. Any questions? Okay, that's it then. Thanks a lot.